Oumuamua, is that what I
Yes,
said?
that's the right thing.
Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Elon Musk just made a startling announcement. A colossal flying object is headed straight for Earth, carrying the force of 1,000 atomic bombs. This object, named Oumuamua, marks the first time an interstellar probe has ventured so close to our planet, and the looming collision could spell major trouble. Scientists have been closely observing Oumuamua since its initial appearance, but they're taken aback by its recent unexpected movement. Could this be an alien attack? And which part of Earth will bear the brunt of this impact? Let's delve into it. Back in 1908, a mysterious asteroid slammed into Siberia, Russia, unleashing destruction equivalent to 15 megatons of TNT. This cosmic clash rivals the devastating power of a volcanic eruption, capable of flattening entire cities and reshaping the landscape around them. The catastrophic aftermath of this event sent shockwaves through the global scientific community and governments, spurring a surge in investments toward space monitoring technology and raising public awareness about the dangers posed by asteroid impacts. However, despite our best efforts, it's tough to fully brace ourselves for such occurrences. In an unexpected turn of events, Elon Musk, the esteemed founder and CEO of SpaceX, has sounded the alarm by warning that an interstellar probe, which made its debut in late 2017, has resurfaced and is now headed straight for Earth. To truly understand the seriousness of Musk's concerns, let's delve into the enigmatic object known as Oumuamua. The name itself, Oumuamua, translating to a messenger from afar, aptly reflects its origins in the depths of interstellar space. Instances of objects from interstellar space entering our Earth's solar system are rare. Yet, the sudden appearance of Oumuamua left everyone baffled. Its distinctive elongated shape, akin to a sausage or hot dog, immediately set it apart from the norm. Initially labeled as an asteroid, Oumuamua defied the typical characteristics of such celestial bodies, which usually sport rounded or irregular shapes as they orbit the Sun within our solar system. Recently, Elon Musk, one of the most influential figures globally, made a startling announcement that has sparked significant attention. There's been much speculation regarding a potential link between Musk's revelation and undisclosed evidence of extraterrestrial invasion. Let's dive into the unique characteristics of Oumuamua's appearance for now. This object displays a distinct structure, almost as if it were intricately sculpted or engineered, and its path through space deviates noticeably. Normally, celestial objects follow predictable velocities observed in other space entities. However, Oumuamua bucks this trend, showcasing a unique and seemingly autonomous speed unlike comets, asteroids, or planets. While comets can zip along at speeds of up to 100,000 miles per hour, depending on their distance from the Sun, Oumuamua's remarkable velocity initially led scientists to consider it a comet. But unlike typical comets, it lacked a visible tail caused by gas emission. Some scientists proposed a theory suggesting Oumuamua might be expelling gas from its sunlit side, propelling it like a rocket, which could explain its unusual speed. However, this theory faced a major challenge: the absence of detectable gas emissions. If Oumuamua were indeed releasing gas, visible signs should have been observed as seen in comets. Yet, no such evidence was found. This lack of a visible tail raises questions about Oumuamua's true nature and origins. In contrast, a comet named 2I/Borisov, discovered in 2019, exhibited rogue comet behavior. Unlike Oumuamua, it sported a massive tail, 14 times the size of Earth, and had fragmented multiple times over the years. The unique characteristics of Oumuamua have given rise to a fascinating new hypothesis. Departing from the typical traits of asteroids or comets, this mysterious interstellar traveler is thought to possibly have originated from a fragment of an exoplanet. According to this hypothesis, an asteroid collision with a distant planet could have ejected fragments into space. From the moment Oumuamua was discovered, it became a puzzle. The Pawn Stars Observatory in Hawaii spotted it first on October 19, 2017. Equipped with one of the world's largest digital cameras, this advanced telescope is designed to identify space objects that might pose a threat to Earth. Contrary to initial beliefs of a cigar or sausage shape, Oumuamua actually measures 377 by 364 by 62 feet in size. When it reached its closest point to the Sun on September 9, 2017, it achieved a remarkable speed of approximately 196,000 miles per hour. Its trajectory around the Sun defied gravitational forces, indicating an origin beyond our solar system. At this point, the alien theory surfaced, causing controversy and concern within the scientific community and among the public. Oumuamua not only exhibited momentum stronger than typical comets or planetary bodies, but also displayed continuous and seemingly deliberate thrust, fueling speculation of it being an alien spacecraft. Some even propose that Oumuamua might be an extraterrestrial probe powered by an unknown internal source. Efforts to ascertain the age of Oumuamua or obtain a close-up view of the object proved futile due to its erratic behavior and astonishing velocity. Its immense speed rendered Earth-based telescopes incapable of capturing a clear image. The enigmatic nature of Oumuamua continues to baffle scientists and space enthusiasts alike. Despite extensive observations and studies, conclusive evidence regarding Oumuamua's origin or composition remains elusive. Its rapid velocity and trajectory made detailed observation challenging, and no signs of artificial technology were detected. Consequently, the scientific consensus tended towards Oumuamua being a natural object, possibly a fragment from another star system. Unfortunately, it seems the scientific community underestimated this phenomenon, and now it poses a potential threat to our planet. How often do interstellar objects invade Earth? In early 2022, astronomers made a groundbreaking discovery, confirming that a mysterious space rock that crashed into Earth in 2014 originated from a distant star system. This finding predates the well-known interstellar visitor Oumuamua by 3 years. Initially spotted by researchers in 2019 through NASA's Center for Near-Earth Object Studies, CNEO's catalog, certain details about its trajectory were withheld by the U.S. Department of Defense, DoD, until March 2022. This release of information enabled scientists to trace the rock's origin. Measuring approximately 3 feet in width, this mini-asteroid made a rapid entry into Earth's atmosphere on January 8, 2014, hurtling at an astonishing speed of 134,200 miles per hour. What made its trajectory remarkable was the indication that it may have originated from beyond our solar system. By tracing the trajectory of the rock backward through time and studying its gravitational interactions with planets in our solar system, researchers confirmed that this small asteroid was indeed a newcomer to the Milky Way galaxy, particularly to the vicinity of the Sun. This confirmation designates the rock, officially labeled as CNEO's January 8, 2014, as potentially the earliest documented visitor from interstellar space, preceding Oumuamua, which passed by Earth in 2017, measuring about 650 feet in width. Just a year later, astronomers spotted Comet Borisov, which measured around 1,650 feet wide. The close succession of these discoveries led scientists to speculate that smaller interstellar rocks, ranging from a few feet to tens of feet in size, might be more common in our solar system and could even regularly intersect Earth's path. Motivated by this idea, distinguished astronomer Avi Loeb from Harvard and his colleague Amir Siraj delved deeper into the CNEO's catalog. Alongside CNEO's January 8, 2014, they identified another intriguing meteor, awaiting the release of classified data. This particular space rock entered Earth's atmosphere in March 2017. The researchers suggest that such occurrences of interstellar rocks entering Earth's atmosphere may happen roughly once every 10 years. Analyzing these meteors could provide valuable insights into the chemistry of distant star systems. In their paper, Loeb and Siraj explained that by retracing the trajectory of each meteor and studying the relative abundances of their chemical isotopes, it becomes possible to link them to their parent stars. This process can unveil crucial details about the formation of planetary systems. Additionally, certain elements found in meteor spectra can also be detected in the atmospheres of stars, establishing important connections to their parent stars. This process can uncover vital insights into the formation of planetary systems. Additionally, certain elements detected in meteor spectra can also be found in the atmospheres of stars, establishing crucial connections to their parent stars. Considering that most meteoroids disintegrate in the atmosphere before reaching the Earth's surface, and that retrieving the few that do make it is incredibly challenging and time-consuming, the researchers propose establishing a global camera network. Such a network would be equipped to conduct spectroscopic measurements, analyzing the light absorption characteristics of incoming space rocks and offering insights into their chemical composition. CNEO's January 8, 2014 broke apart above the ocean near Papua New Guinea, as disclosed by Siraj. The scientists suspect that some fragments of the rock may have survived the atmospheric journey and fallen into the sea. Siraj and Loeb intend to organize an expedition in the coming year to retrieve some of these fragments. Furthermore, they suggest that the frequency of interstellar visitors throughout Earth's history implies that the building blocks of life on our planet, which emerged over the past 3.5 billion years, may have originated from another star system. Oumuamua's visit to our solar system was fleeting, and it was soon declared beyond our reach. Recently, it has been confirmed that the object is hurtling toward Earth at an incredible speed. Several researchers had anticipated this and had attempted to intercept Oumuamua before its collision with Earth. Unfortunately, what made this situation even more disheartening was the failure of the most accurate predictions to account for the present time, as many scientists were certain that Oumuamua would not return during this decade. And now, the moment we've all been anticipating. Elon Musk's primary concern is that the impact of Oumuamua on Earth will likely be 4,000 times the collision of the Chelyabinsk meteor. Wait, what is the Chelyabinsk meteor? The Chelyabinsk meteor event of February 15, 2013 unfolded with the force and spectacle of a cosmic fireworks display. Like a celestial bombshell, a massive meteoroid pierced the Earth's atmosphere and erupted in a brilliant explosion above the Russian city of Chelyabinsk. The sheer force of the blast and its ensuing shockwave had a profound impact, causing extensive damage and numerous injuries. Picture a massive cannonball hurtling through the sky at an astonishing speed of approximately 19 kilometers per second. As it descended into the atmosphere, its relentless momentum clashed with the Earth's protective shield. This collision of forces led to an incredible release of pressure and heat, resulting in the meteoroid disintegrating and exploding at a staggering altitude of around 29.7 kilometers above the planet's surface. The resulting explosion unleashed cataclysmic energy equivalent to roughly 440 kilotons of TNT, an awe-inspiring demonstration of sheer power. The shockwave from the blast shattered windows, caused structural damage to buildings, and resulted in injuries to over 1,500 individuals. Most injuries were caused by shattered glass and debris propelled by the shockwave. Fortunately, there were no reported fatalities directly attributable to the event. Nonetheless, it served as a stark reminder of the potential dangers posed by near-Earth objects, NEOs, and highlighted the urgent need for enhanced efforts in monitoring and mitigating such threats. From a scientific perspective, the Chelyabinsk meteor event sparked considerable interest. It provided valuable data for studying the behavior of meteors during atmospheric entry and the resulting shock waves. Researchers meticulously analyzed numerous video recordings captured by eyewitnesses, aiding in determining the meteoroid's trajectory, velocity, and other characteristics. The event underscored the importance of international collaboration in monitoring and detecting potential impact hazards. In the wake of the Chelyabinsk meteor event, there has been a heightened focus on enhancing global asteroid detection and tracking systems. Space agencies like NASA and others worldwide have been tirelessly working to improve their capabilities in detecting and characterizing potentially hazardous asteroids. Despite significant efforts invested in early detection and developing planetary defense strategies, no one is prepared for the impact of the impending collision with Oumuamua. What would happen if Oumuamua collides with Earth in the next 32 hours? A collision with Earth would unleash a global catastrophe of unprecedented scale. Oumuamua, this enigmatic interstellar object, believed to be a dense mass of metal or rock hurtling through space at immense speeds, would encounter extreme friction upon entering our atmosphere. Consequently, it could disintegrate or explode before reaching the surface. However, if it managed to defy the odds and make contact, the consequences would be devastating. To comprehend the potential destruction, we must consider the concept of impact energy. This measure, determined by the object's mass and velocity, quantifies the tremendous amount of energy released upon collision. While the exact mass of Oumuamua remains uncertain, it could range from hundreds to thousands of tons, given its elongated shape and estimated density. A larger object would carry significantly more energy. To put this into perspective, a standard nuclear bomb's energy is measured in kilotons, equivalent to thousands of tons of TNT. For instance, the bomb dropped on Hiroshima in 1945 released energy equal to about 15 kilotons of TNT. In contrast, Oumuamua's impact, even if it were relatively small, would be measured in megatons or gigatons of TNT equivalent. To provide context, the largest nuclear bomb ever detonated, the Tsar Bomba, released energy equivalent to around 50 megatons of TNT. However, if Oumuamua were larger or traveling at higher velocities, its impact energy could potentially reach into the trillions of tons, resulting in an unimaginably destructive global event. The potential outcomes of such a catastrophic impact are profound. Oumuamua could present a global extinction threat, capable of decimating a significant portion of life on Earth, including various species, including humans. Throughout history, mass extinction events have occurred due to catastrophic incidents like asteroid impacts. The most notable example is the Cretaceous-Paleogene extinction, which wiped out the dinosaurs approximately 66 million years ago. Oumuamua's impact could trigger a similar mass extinction event. The immediate consequences of Oumuamua's impact would be dire. The collision would ignite massive fires, generate tsunamis if it struck an ocean, and cause earthquakes, resulting in loss of life and destruction of ecosystems. Additionally, the tremendous energy released upon impact would propel vast amounts of debris and dust into the atmosphere. This atmospheric contamination would block sunlight, leading to a dramatic drop in global temperatures. The resulting nuclear winter effect could persist for months or even years, disrupting global climate patterns and severely impacting agriculture and food production. The combination of immediate devastation and prolonged climate disruption would place immense stress on ecosystems, leading to the collapse of fragile species and a domino effect of extinctions. However, the consequences of Oumuamua's impact extend beyond immediate devastation and climate disruption. The global ecological balance would be disrupted on a monumental scale. The destruction of habitats and ecosystems caused by the impact would result in the loss of countless plant and animal species. This loss of biodiversity would have far-reaching consequences, affecting the intricate web of life on Earth. Species that rely on specific ecological relationships and dependencies would face extinction, leading to cascading effects throughout the food chain and ecosystem functions. In addition to the ecological consequences, Oumuamua's impact would bring about significant geopolitical and socio-economic disruptions. The impact's devastation would lead to the loss of critical infrastructure, including transportation networks, communication systems, and power grids. Governments would struggle to maintain law and order, potentially resulting in social unrest and conflicts over scarce resources. the global economy would suffer a severe blow with disruptions in trade, supply chains, and financial systems. The loss of agricultural productivity, along with the breakdown of distribution networks, would cause food shortages and widespread famine. The psychological and emotional toll on human survivors would be immense, with long-lasting effects on mental health due to the trauma of experiencing such a catastrophic event and the loss of loved ones. Communities and societies would be tasked with rebuilding their lives amidst profound loss and uncertainty about the future. Scientific progress and technological advancements would also suffer significant setbacks. Resources and efforts that would normally be directed towards scientific research, space exploration, and technological innovation would instead be diverted toward immediate survival and recovery. This setback in scientific and technological progress could have long-term implications for humanity's ability to understand the universe, develop new technologies, and address pressing global challenges. However, amidst the grim outlook, there is hope. Scientists, both in government and private sectors, actively monitor and track near-Earth objects, assessing potential threats and developing strategies for planetary defense. Early detection systems and deflection methods are being researched to alter the paths of celestial objects that could endanger our planet. By investing in these efforts and advancing planetary defense technologies, we increase our chances of mitigating the catastrophic consequences of potential impacts from interstellar objects like Oumuamua. Elon Musk's reference to the Alvarez hypothesis underscores the gravity of the current concern. This fascinating hypothesis, formulated by father and son scientists Luis and Walter Alvarez in the late 1970s, remains relevant today. Alvarez's hypothesis proposes a link between a colossal asteroid or comet impact and the mass extinction event that wiped out the dinosaurs approximately 66 million years ago. This groundbreaking theory suggests that the impact of a celestial object set off a chain of catastrophic events, resulting in the extinction of numerous species, including the formidable dinosaurs. According to the Alvarez hypothesis, the impact of an immense extraterrestrial object on the Earth's surface released an enormous amount of energy, ejecting a vast quantity of debris and dust into the atmosphere. This ejected material then enveloped the Earth, blocking sunlight and causing a significant drop in global temperatures. Consequently, the planet experienced an extended period of darkness and cold, severely disrupting the delicate balance of ecosystems and jeopardizing the survival of many species. If a collision similar to that of Oumuamua were to occur, it could spell catastrophic consequences for life on our planet. The immense energy released upon impact would create devastating shock waves, leading to widespread destruction and potentially triggering a mass extinction event. The resulting dust and debris ejected into the atmosphere would veil the Earth, causing an abrupt and prolonged decrease in temperatures, disrupting ecosystems and imperiling countless species. Elon Musk acknowledges that addressing the issue of interstellar object collisions necessitates a global collaborative approach. He advocates for increased cooperation among nations to develop detection systems and mitigation strategies. By pooling resources, knowledge, and expertise, countries can enhance early warning systems and devise effective methods to divert or mitigate the impact of these objects. Musk believes that only through international collaboration can we maximize our chances of safeguarding our planet from potential catastrophic events. Elon Musk is keenly aware of the lack of public awareness surrounding the threat of interstellar object collisions. Despite the significant potential consequences, this topic remains relatively obscure to the general public. As a result, Musk emphasizes the need for heightened public education and outreach initiatives to raise awareness about the dangers and potential solutions. He believes that by fostering a greater understanding of the risks and involving the public in discussions, we can collectively strive towards a safer future. Thank you for watching. Please remember to like, comment, and subscribe. See you in the next video.